In this next section, we're going to talk about graph transformations, which specifically means looking at what causes a function to shift either horizontally, vertically, or reflect over the x or y axis. So we're going to begin by establishing some rules for each of these situations. So let's begin with the function f of x is equal to x squared. And then also the function f of x is equal to x squared plus 3. And so we want to compare these two functions and their graphs. So f of x is equal to x squared is going to be this one. And f of x is equal to x squared plus 3 is going to be this one. And the only difference in the two equations is that in the second equation, I added plus 3 to the end of the function. And look at what happens. If I look at my vertex of the parabola, here it's sitting at 0, 0, and here it's moved up 3 units. So I could conclude that adding 3 to the end of the function will cause the graph to shift up. So I'm going to go ahead and jot that down as a rule. If I want the graph to shift up, I'm going to add a number to the end of the function, which should cause that shift to occur. On our next example, we're going to compare f of x is equal to x squared, which again is this graph, to f of x is equal to x squared minus 2, which will be this graph. Again, the only difference between our two functions is that on this second one, I have put a minus 2 on the end of the function. And look at what happens between the graphs. We start with a graph that has a vertex at 0, 0, and when we subtract 2 from the function, the entire graph shifts down 2 units. So again, I can make a conclusion that says if I subtract a number from the end of the function, it's going to cause the graph to shift down. So if I add a number to the end of the function, the graph shifts up. If I subtract a number from the end of the function, the graph shifts down. Let's now consider our left and right shifts. So we're going to compare the function f of x is equal to x squared, which again is this graph, to the function f of x is equal to the quantity x minus 4 all squared. And so you notice by looking at your graph, your original graph again sits with the vertex at 0, 0. Your new graph has now shifted 4 units to the right. So there's two things that we want to point out here. In order to get from the x squared graph to the x minus 4 squared graph, what needs to happen is you need to take your original graph and make a substitution. So in place of the x, so I'm going to erase the x, so in place of the x, I'm going to substitute in x minus a number, in this case, x minus 4. So it becomes a part of the function. Okay, so it's a substitution to cause it to move to the right. The other thing that is interesting is that we are subtracting the number, but it's causing the graph to move to the right, which I think is a little counterintuitive. Normally when we see a negative, we think it's going to move to the left, and so it is doing the opposite of what I might expect here. All right, so I'm going to go ahead and summarize that as a rule for you. So we'll say if we want the graph to shift horizontally to the right, we're going to replace x in the function with x minus a number, and that should cause the graph to shift to the right. Let's look at one where the graph is shifting to the left. So we're going to compare f of x is equal to x squared to the graph of f of x is equal to x plus 2 squared. So again, our original graph sits with the vertex at 0, 0. Our new graph, because of the x plus 2, is going to shift 2 units back to the left. So again, this horizontal shift, either left or right, is a replacement of x in our function. So if we take our original function, f of x is equal to x squared, and we erase the x, and in its place we put x plus a number, and in this case we're using 2, then that's going to create the new equation, which will cause the graph to shift to the left. And again, keeping in mind that this plus makes me think it's going to move to the right, but in actuality it causes a left shift. All right, so summarizing that rule, in order to cause a graph to shift to the left, we need to replace the x in the function with x plus a number. We'll now look at our reflections. So we want to compare the graph of x squared to the graph of negative x squared. All right, so essentially what I have done is I have taken my function, which is x squared originally, and I have multiplied that function by -1. And when I do that, I'm going to get this. Okay, so multiplying your function by -1, note what happens in the graph. It's going to cause the graph to reflect over the x-axis. So remember, your x-axis is this horizontal axis, and so the graph is essentially going to flip over that x-axis, and instead of opening up, it's going to open down. And so that is caused by multiplying your function by -1. So our rule says if you multiply the function by a -1, that will cause the graph to reflect over the x-axis. So now let's look at a graph where it's reflected over the y-axis. And I did change our original function simply because if we have a parabola, the one we've been working with, and we reflect it over the y-axis, it doesn't actually look any different. So I wanted to pick one where we definitely can see the difference of the reflection. So again, this is a replacement. So you are taking your original function, which in this case is x cubed. You are erasing the x, and in its place, you're putting a -x. And so when you do that replacement, when that negative becomes a part of the function, you are looking at a reflection over the y-axis. Remember, your y-axis is your vertical axis here. And so you can see that going from the original graph to the one on the right, we are reflecting, mirror imaging over that y-axis. So again, as a rule, to reflect over the y-axis, we're going to replace the x in the function with a -x. And in actuality, I probably should have put a set of parentheses here, because that's going to be the best way to do that replacement, is to keep that -x in a set of parentheses. But that will cause your graph to reflect over the y-axis. So now we've covered the vertical shifts, the horizontal shifts, the reflection over the x-axis, and also the reflection over the y-axis.